You can hear what they said. In the other class, I literally just answered math problems for them. That's what they wanted to do. They asked questions about the homework, not the problems. They asked about all the homework questions, and I went over a bunch of them. So if you want to watch that video to practice some of the homework, it was from 5.2 and 5.3 homework. Those are the questions that were asked. Okay, so that's more review if you need to tonight. For you guys, what I'm going to do right now is go over the general idea, because we just did like 4 problems, right? Instead of continuing with problems. For them, it was just one day of review real quick. So what I want to do is quickly go over concepts that are involved. Okay, the ideas you need to know throughout this. So there are some things that we've talked about. We've talked about friction. We've talked about 2 types of friction. We've talked about static and kinetic friction. How do they really differ? Static versus kinetic. Static versus kinetic. What's the major difference here? What is that? In static? Yeah, static or stationary. What do we know about the values of kinetic and static friction? Which is greater? Does it take more to get something moving, or does it take more to keep it moving? Yeah, it takes more to get it moving. Static is greater. Again, it's harder to push a desk and get it moving. Once it's moving, it will move a lot easier because A, it's got inertia to it, it wants to move, and B, the actual coefficient of kinetic friction is less than static. What else? Normal force always reacts against gravity. It always pushes back up off the ground against gravity. I'll give you a little tidbit. So because tomorrow is a D-Day, it's a shorter period. So what I've done is, for the math part at the end, instead of making you do all the problems, I'm letting you omit one of them. Okay, so you'll have either 3 or 4 problems, and I'll say choose 2 out of 3 to answer, or choose 3 out of 4 to answer. Keep that in your mind when you're studying. You can omit one question. I will guarantee you that you'll have a question mathematically about static, mathematically about kinetic, both types of friction, and then there'll be probably one question with a force at an angle. So there's going to be a force at an angle, and that can be static or kinetic, obviously, but in general, you're going to have kinetic and static. Don't jump to omitting the force at an angle just because it's at an angle. All it takes is those 2 components. That actually, I think, is one of the easier problems on this, because the other ones involve other stuff. So don't automatically assume that you're going to omit the one that's at an angle just because it's at an angle. All you got to do is break the force in 2 directions. You'll have about 10 multiple choice. These multiple choice on this test, I was looking and making the test last night and trying to come up with some new questions and good ones. And I was looking at other textbooks, and your current textbook, I use questions that are there all the time. And I felt that there were a lot of reasonable multiple choice questions. One thing I need to really emphasize, you shouldn't be spending more than like 30 seconds to a minute on a multiple choice. If you find yourself sitting there, you're wasting your time. Say you would spend a minute per question, multiple choice, that's 11 minutes. It means now, out of 37 minutes, you have 26 left. There are going to be 2 short answer problems. Part A and B, Part A and B, similar to what we've done in the past. Those might take you 2 minutes each, that's 8 minutes. That drops you to 18 minutes. 18 minutes to do 2 or 3 math problems. If it's 2 math problems, that's 9 minutes each. If it's 3 math problems, that's 6 minutes each. So you need to pace yourself accordingly. If you have extra time, you need to make sure you actually ask me for it. And don't assume that I'm going to be available if not. You need to actually schedule your extra time. Tomorrow's tests are first and second period, which leaves a lot of freeze during the day for you to come make up your extra time. I prefer it to be during the day and after school tomorrow. I prefer it to be during the day. There's a lot of freeze after second and third. I do not want you waiting all day before you finish the test and then you're nervous all day. If you get extra time, you have to tell me ahead of time because I have to separate your test. Too many of you forget to do that. If you do not ask ahead of time, you get the whole test, you're taking the whole test. You can't see the whole test and then come back later and work on it. It's not fair. Other ideas I want you to consider. Mass and weight are very different entities. Explain the difference between mass and weight.
Weight is affected by gravity, and mass is just a second.
Yeah, mass is a set value. Mass is the amount of matter, or remember the other definition, the measurement of inertia. The measurement of inertia of an object. The more inertia, the more mass. If I'm very massive, it's hard to move me. I have a lot of inertia. If I'm moving, imagine, remember Jerome Bettis from the Pittsburgh Steelers, right? It was called the Fridge. It was his nickname. He was this huge running back. Was it Bettis? Who was the Fridge? Who was the Fridge?
He was on the Bears.
Oh, the Bears, that's who it was. He was this huge running back. He would come in on these 4th and goal plays where he would just barrel through the line because he's massive. Someone who's that big is able to have a lot of inertia because they're moving, and as they're moving, it's hard to stop them. So mass is really a measurement of inertia. I gave the example with the golf ball and the bowling ball, trying to hit them. But gravity affects the weight of an object. Gravity, or the weight of an object rather, is mass times gravity. Mass times gravity. If you know the weight and you want the mass, just divide by gravity instead. Use logic, right? If I give you the weight and you want the mass, divide by gravity. If you're given the mass, you multiply by gravity to get the weight. Or inverse operations, obviously. You need to understand direct and indirect variation applying to these laws. So, we have two real equations. We've got this one, our general equation. Then we've got friction. We also had the weight of an object equals mg. These were our main three formulas. The more force you apply, the more acceleration it has. Those are directly related. The more force applied, the heavier mass you can move. Those are directly related. Down here at the bottom, friction. The higher the mu value, the rougher the surface is, the more friction. The higher the normal force means that you're sitting on it. Remember I gave the example of the chair? Somebody that's sitting on a chair, you try to move them, it's almost impossible because they're pushing down, so normal force goes up. So normal force and friction are directly related. In 5.2, we also talked about a formula for Hooke's law. The other class asked a question about this from the homework. I also went over that one. So if you'd like to see a mathematical problem for this, an idea of how it works, look at the other class's review video. Idea-wise, theoretically, this concept is that if you pull on a spring, what does the spring do? It stretches. What does it want to do? It wants to go back to its original shape. So if I have a spring attached to something, the spring is like a bungee cord. Think of a bungee cord. You pull on a bungee cord, what happens when you let go? It shoots back, because which way is the force pulling it? Back. That's why this is negative, by the way. And you saw this in 5.2 in the part of the video you were supposed to watch on your own. So if for some reason you didn't do that yet, you need to get on this stuff. Okay, this is in 5.2 when you watch Hooke's law. The more you stretch X, the more the spring wants to pull back. What is K?
The force.
It's not the force is F. K is something else.
Like how stretchy the spring.
Very good. The strength of the spring. It is measured in newtons divided by meters. For example, if a spring has a rating of 7 newtons per meter, it means it takes 7 newtons to stretch it 1 meter. That's what it means. Literally. If the number is 50 newtons per meter, it takes 50 newtons of force to stretch something 1 meter. The higher the K, the stronger the spring. For example, a slinky. You've used a slinky before, right, as a kid? You haven't used a slinky, you know what a slinky looks like? It's a very, very, very weak spring. So a slinky can be easily stretched. By just pulling on it. I'm putting very little force in this stretch, like 3 or 4 meters. So this K value is very low. There's a very low K value in this slinky. Now, if you take your pen and you try and stretch the spring that's inside of your pen, it'll ruin your pen, so don't do it. But if you try to, you'll see that that's actually a stronger spring than a simple old slinky. An example of a very strong spring or a very high K value, the springs on your car. The shock absorbers, when your car hits a speed bump, why doesn't it do this forever? It automatically dampens. There's a damper and there's a spring system. So the spring damper system. The actual system, the spring itself contracts and automatically pulls the car back into place because it's a very rigid spring. It would take a lot of force to stretch it. That's a high K value. Yeah.
That's newtons divided by meters.
Yes. And the reason I can tell, look at my units. The units of this are newtons for Fs. The units of X, which is how much it stretches, is meters. So how would I get this value by itself? I would have to divide both sides by meters, right? Divide by meters, and I would get this by itself. So there's my units, newtons per meter. Okay? If you really have no idea what I'm saying, you need to do your homework. You need to have watched this video. I'm not going to go on about springs more after this. Okay, I did an example in that video and with the other class.
Well, I just have a question about the displacement.
Yeah.
Is it always going to be negative? Because it's always a displacement at the end.
So here's what it is. When you have that's a great question actually. When you have an object, it depends on which way it's pulled or pushed. So if I take this object, and this is the spring right here, and I pull it this way, however far it's been pulled, that's X, that's positive. But if I push it this way, this is how far it's been compressed, that X would be negative. Okay? So again, tonight, make sure to practice, make sure to go over your stuff. Look at documents and handouts for those 4 examples. Look at your problem set. Okay, I really hope you listened to me and got a head start, or else tonight's going to be a rough night. Email me for extra time, please.